Hello friends and welcome for another lecture of DEM. Hope you all are taking necessary precautions and safety measures against the COVID-19. In last lecture we have completed the mean max terms. Also we have completed the Boolean expression representation in the form of sum of products, product of sums, conversion of sum of product or product of sums into canonical form. And now in this lecture we are going for the Kmap maps, which is one of the simplification technique for the Boolean expression along with the Boolean algebra that is to be. So let's start with the Kmap maps. So Kmap maps, which are also termed to be Kmap, are the graphical representation of the Boolean function. In a graphical form, when the Boolean functions will be represented, it is a way of simplifying the Boolean expression, and it is more systematic way as compared to the Boolean expression simplification by using the Boolean algebra. In this Kmap map, we will have the simplest SOP or POS expression to be obtained, which is said to be the minimum expression after the simplification of Boolean expression. In this Kmap map, each cell will represent the two different things, or they can be equivalent to the two different things corresponding to the truth table and the Boolean expression. So one single cell in Kmap map corresponds to a row value in the truth table of the Boolean function. Also, this single map cell in Kmap map will represent either a mean term or a max term in the given Boolean expression. So we can say that a map cell into Kmap map is equivalent to a row in the truth table and a mean term or a max term for the Boolean expression, while the multiple cells in the Kmap map will correspond to the different standard term. We have said that a Kmap map cell is similar to a truth table row representation because the cell is corresponding to the input and output organization in form of a column and a row for the Kmap map represent. Again, we have said that Kmap map is an array of cells, and each of that cell will represent the binary value of the input variable. Obviously, that binary value will be either 0 or 1. That means your variable will be in original form or in complemented. In the Kmap map, the cells arrangement is done in specified way, and that specified way of cell arrangement will give us the simplification of the given Boolean expression. And for getting that simplification of the Boolean expression, the cell number of cells are to be grouped in proper order, or in which will be explained in the further coming slide. And for these Kmap maps to be prepared, we are going to use either the expressions corresponding to 2 variables, 3 variables, 4 variables, or 5 variables. But we are sticking only for up to 4 variables for getting the simplification by Kmap map. So let's start with the 2 variable Kmap, friend. So as we are saying, it is a 2 variable Kmap. So definitely the Boolean function will be a function representation of 2 variables. Let's say those variables as x1 and x2. So for plotting this map, I can take x1 variable as a row, or I can take the x1 variable as a column. So both of these representation has been given over here. So in this first map representation, x1 variable has been taken as a column variable, while in the second map representation, x1 variable has been taken as a row variable. Now the cell 0 always represents the complement values of both the variables, whether you are considering x1 as a column or x1 as a row variable. The first cell, that is 0, 0, will represent the complemented form of both the variables as indicated over here and here. But for the column variable of x1, here horizontally the first term will be place, and if I am taking x1 as a row variable, vertically that first term will be present. The first term will be obviously x1 dash x2, that is complemented form of x1 with x2. Now when we will give the arrangement of these variables as like in the Kmap map, as it is a function of two variables, so possibly 4 combinations we will get, because 2 raised to 2 is nothing but 4, and that's why in this two variable map totally 4 number of mean terms will be present. Either you take this presentation or this presentation. Here we will find 4 terms m0, m1, m2 and m3, while this will be as m0, m1, m2 and m3. So in the given expression, if suppose out of these 4 terms which mean term is present, corresponding to that the cell value will be placed as 1. Corresponding to that the cell value will be placed as a 1. This is how in the Kmap map the mean term presence or absence will be indicated by the magnitude as 1 or 0 for this m0, m1, m2 and m3 in this drawn map. For any Kmap map there is concept of the adjacent cells. So these adjacent cells are always differed by only one variable, and these differing variable may be complemented in one cell and uncomplemented in the other. Let's take the first cell example, that is m0. For this m0 to be represented, we are writing it as a x1 dash x2 dash. If I am going for horizontally, here the first variable which we are plotting adjacent to this m0 will be x1 dash x. So here we can see that x1 dash is common, but x2 is present in first cell in complemented form, while in the second cell it is in uncomplemented form. Now again we will take the example of m0 and this m0, as earlier said, it is x1 dash x2 dash, while this m2 will be x1 x2 dash. So we can find out for this that x2 dash is common now, but x1 is present either in complemented form or in uncomplemented form. But if I consider m3 value will be x1 x2 and m0 value is x1 dash x2 dash. So I cannot say that m3 is a adjacent cell for this m0. Rather than that, the variables which are varying for a single variable in the adjacent cells will be said to be the adjacent cell. Let's take one example and the simplification of this Kmap map by using the Kmap map simplification. So the function which is for two variable has been given with this as x1 dash x2 dash, ORed with x1 dash x2, ORed with x1 x2 dash. So first thing what we have to do is we have to represent these given variables from the Boolean expression in form of mean terms. So first mean term will be m0, the second term will be m1 and the third term will be m. So let's check for the representation of the Boolean function. So x1 I am taking in form of a column. So this will be m0, this will be m1, this will be m2, will be m0, this will be m1, this will be m2 and this will be m. In that case when I am taking x1 as column variable. So let's put the value 1 for the mean terms which are present in the given Boolean function. So m0 is present, we are putting 1 for that, m1 is present, so 1 is put over here, and m2 is again present, so another 1 is placed over here. After placing the presence of mean term by 1 value and the absence of mean term by 0 value, we have to get the grouping of mean terms to be done. And these mean terms are grouped by using the rule that in a group there should be 2 raised to k number of variables. That means here either in the group we have to have 2 number of ones, 4 number of ones or 8 number of ones and so on. Here we can have the two group which will be having the 2 number of ones. So one group will be obtained horizontally and the other group will be obtained by getting the grouping vertically. So we will, let's simplify the term for this horizontal terminology. So that will be x1 dash x2 dash and x1 dash x2. So here x2 is in uncomplemented form and here in complemented form. So x2 will get cancelled and the remaining term for the first group will be x1 dash. In the same way, here for this vertical group we can see this term is x1 dash x2 dash while this term is x1 x2 dash. So x1 is in complemented and uncomplemented form, so it will get cancelled with each other and remaining term is x2 dash. So from this grouping we can get the simplified resultant as x2 dash. So we can say that from this given Boolean function which is consisting of p number of mean terms, from that we have obtained the simplified version which is consisting of only 2 variables instead of having the 4 or 5 number of different variables. Now we will shift towards the 3 variable Kmap. Now when the number of variables will be 3, obviously there will be presence of 2 raised to 3, that is equal to 8 number of cells and 8 number of mean terms for that Kmap to be plot. Again, in that, for plotting the Kmap, either I can take a single variable as a row as mentioned over here, or the column as we can do in the other way. So here, as the 2 variables we are taking on as a column, so for the column the separated rows will be 4 in number, but they are to be placed in such a way that at the next time only one variable change has to be happen. And that's why here in the column placing, please take a note that after 0 1 we have not put 1 0, but we have placed here 1 1 and then we have gone for 1 0. The reason behind this placement is that for the adjacent cells only a single variable change has to happen, but if we are placing this 1 0 after 0 1, this will be presence of 2 variable changes, and that's why here after 0 1 1 1 has been placed and then 1 0 has been placed. So please take a note of this placement for forming the 3 variable K. In that case, this first term will represent the mean term 0. Second term will represent the mean term 1, then this will represent the third term, this will represent the fourth term, this will represent fifth term, this will represent the sixth term, seventh, and this will be the eighth term representation. So here you can see 1, 2, 3, 4, 5, 6, 7 and 8. Likewise the placing will be done. Now again let's take the expression as y is equal to a dash b dash c dash, or with a dash b c dash, or with a b dash c, and or with a b c. So here this a dash b dash c dash will be equivalent to 000. So this mean term is present, so we will be placing at this first mean term position the value as 1. The next mean term which is present in the expression is a dash b c dash, so it is equivalent to 0 1 0. That 0 1 0 will be present at the location over here at the second position, so here we will place the value as 1. The third term which is present over here is a b dash c. A b dash c is equivalent to the presentation as 1 0 1, and this 1 0 1 will be present at fifth location, so fifth location value we are placing as 1. Next term present in this part is ABC, which is equivalent to 1 1 1. This 1 1 1 is presenting the 7th mean term, and the 7th mean term position is over here, so this mean term cell position will be replaced with the value of 1. Now when we are getting this, after getting this, we have to group the mean term in the form of 2 variables or 4 variables. So here you can see the variables which we can group will be this vertical grouping and this another one vertical. Now from this first vertical grouping we can see that C dash is commonly present, A dash is also commonly present, but B is in original and in complemented form. So the resultant of this grouping what we can get is A dash and C dash. This second term will be present. As a result of grouping of these two variables vertically, we can see the common term which is present for this is C and the term present is 1, but here B is present in complemented and uncomplemented form. So we can find out the resultant for this grouping will be A and C term. So this total simplified variable resultant for the 3 variable Kmap will be now obtained as y equal to AC OR with A dash C dash. We will shift to the 4 variable Kmap. Just look for the placement of these variables in the Kmap cell arrangement. As I have earlier said, the adjacent cell values should change corresponding to only one variable, and because of that in the column arrangement also and in row arrangement also, after 0 1 we have to place 1 1 and then the 1 0 value in column also and in row. And if we are doing such of the placement for these variables, we can find out the mean cells which can be arranged as 0 1, but now here third term will come and then second. In the second row, fourth term, fifth term, then in the last column, sixth term and seventh term will appear. Now after doing this, instead of the third row, we have to go towards the fourth row for the placement of next mean term cells. So that last row mean terms placement will start from 8, 9, then ending cell will be having 10 value and then it will be 11. After that for the third row it will be 12, 13. This ending cell will be of 14 and this will be 15. Totally the 16 mean terms will be present which are starting from 0 to 50 in the 4 variable K, because 2 raised to 4 will make totally 16 number of possible mean terms out of 4 variable combination. And that's why here the placement for the 4 variable Kmap will be given with the indication of these mean terms mentioned in the. For the simplification, as we have done in the previous cases of 2 and 3 variable, the first step is we have to place the value of mean term which are present in the given Boolean expression to be indicated by 1 and the absent terms will be represented by. After getting the placement to be done, we have to do the grouping of the adjacent cells, or they may be common or we can get that horizontally or vertically. After doing the grouping of those ones, in the next step we have to give the output to be obtained from each group by doing their simplification by grouping of the one. Finally, the final output after the simplification from each of the group that we have to, and while forming the group, more number of possible groups that we have to form. And at the same time, we have to look for the groups to be made for more number of ones to be obtained. Let's check for the grouping for this given table. So in this given table, we can find out 2nd, 3rd, 4th, 6th, 12th, 14th, 11th and 10th member of the term will having presence into the Boolean expression, so they will be indicated by 1, while other terms are missing from the Boolean expression, so they have been mentioned as 0. So after placing 1 and 0s in the Kmap, we have to get the grouping to be done, and in that we have to go for the grouping to be done in such a way that we can get a group which is consisting of more number of ones. So let's try for this vertical group which is consisting of 4 number of ones. Again we can get the grouping which is having these 2 ones and these 2 ones, that is these 4 ones to be grouped up. In the same manner, we can find out this ending group of 2 ones will be combined with the another group of 2 ones over here. So after this, for each of the group, the simplification we have to give up. So let's start with the simplification for this first group of 4 ones. So in this 4 ones group, we can find out in this part the term A is in uncomplemented form, but in these 2 parts it is in complemented form. At the same time, here we can find out that this term is existing with B in complemented form and here in uncomplemented form. Similarly, it is in uncomplemented form and it is in complemented form. So whenever I will take this whole 4-bit combination, the resultant will be only this common term of 1 0. That means it will be C D dash. So resultant for this 4 ones grouping is C D dash. Now let's try for this grouping of 4 bits. Here we can find out the term which is cancelling is A, because A is present in complemented and uncomplemented form, but B is present in uncomplemented form, and for these two terms it is C dash D dash. So resultant for this will be B C dash D dash. While for this particular term, again we can find out that A is present in complemented and uncomplemented form, so it will get cancelled. B is remaining as it is, and here it will have the term as C D dash. So we will have ORing of this resultant of B C dash D dash ORed with this term of B C D dash. So here D term will be in complemented form, while here the D term is again in complemented form. So resultant of this will be nothing but B D dash, and C and C dash complement terms will get cancelled for the resultant of this 4 ones grouping. Similarly, over here we are seeing that D term is present in complementing and uncomplemented form, so that will get cancelled with each other. And here for this line and for this line we are finding that B dash is common, but A is present in complemented and uncomplemented form. So the resultant for this 4-bit ones grouping is that B dash C. This is how the simplification will be done for the given Boolean expressions by using either 2 variable, 3 variable or 4 variable Kmap map. But while doing this minimization by using the Kmap maps, some of the rules for grouping that we have to remember, and those rules in the succeeding slides I am going to explain. The Kmap will be used for getting the simplification of Boolean expression to have its minimal form, and its minimal form will indicate that either less number of mean terms will be present, or in every individual mean term less number of literals will be present. This minimized sum of product expression contains the fewest possible terms with the fewest possible variables per term. And generally, these minimums SOP expression will be implemented with the fewer logic gates than the standard expression. And that's why this Kmap is having advantage to get the minimization in the logic gates for implementation of Boolean expression. So we'll go for different rules of grouping. For grouping, we have to always use only the value of mean cells as a 1. We cannot group the value of mean cells as a 0 and 1 for the grouping, which is totally wrong. Also, if suppose the ones are placed in diagonal manner, we cannot do the grouping of those ones. Those ones should be present in adjacent cells only, as like over here. If they are present in the adjacent cells, then only we can do their grouping either horizontally, or we can give the vertical grouping also. The next rule says that the elements in a group should be always the 2's power value. That means in a group we can have either 2 ones, 4 ones or 8 number of ones to be included. never we will have a group of 3 ones as like indicated over here, or a group of 5 ones as like indicated over here. Always the elements in a group should be the 2's power, that is group of 2 ones, 4 ones, or 8 number of. Again, for forming the groups, we can have the overlapping of the groups also, which is permissible one for getting the less number of variables in the minimized form. So here you can see that for the given placement of ones, we can make a group of 2 ones, and such like this 3 number of groups can be formed. But as a resultant of each of this group, we will find out the 2 variable mean terms, but they will be 3 in number. So instead of this, here we can form a first group of 4 ones, similarly the another group of these 4 ones. And if I am doing this, I can have only 2 mean terms as a resultant of simplification of these grouping of the Kmap. And that's why we have to go for applying the grouping of ones, which will consist of more number of ones, but that should be the 2's power. So here instead of making the group of 2 ones, we can go for making a group of 4 ones. Then the next rule says that minimum number of possible groups have to be formed. And for forming that minimum number of possible groups, again the same part we can explain over here. So instead of having 3 groups of 2 ones each, we can have 2 groups of 4 ones each. Again, for the grouping, we can use the grouping like this also, wherein I can have these ones at the ending that can be grouped with these 2 ones at the ending. At the same time, I can make the group of these 4 ones. I can make the group of these 4 ones, and also by getting these corner ones, I can have another group of 4 ones. So likewise, the grouping whichever is possible in the given Kmap placements that we have to form. So let's say that a given SOP has to be converted into the Kmap. So whenever a SOP expression will be provided, we have to look for which mean terms are present into that SOP expression. The mean terms which are present into that SOP expression, for them we have to place the magnitude as 1. Otherwise, the mean terms which are absent in the given SOP expression, we have to place that as zeros. So in the given expression, the first term is a dash b dash c dash, which is mean term 0, so that has been placed as 1. Second is the mean term as a dash b dash c, which is as a second mean term, that is placed as 1. Then next term is a b c dash, that a b c dash will be placed over here with the magnitude as 1, and last one is a b dash c dash, which will be placed over here with the magnitude of 1. Now the simple examples for grouping has been shown with the presence of these variables. In the first example, we are having that we have to consider that all these K-maps are corresponding to 3 variables. So in the 3 variables, we have taken here 1 variable in a column and 2 variables in the rows combination. So please note that here for the variables which has been taken as a row, in the placement after 0 1, we have to get 1 1 to be placed, as the adjacent cells has to vary for a single variable. And the SOP has been having the presence of 0th term and the 4th term. So here the 0th term will be placed as a 1. This will be 0th term, first, second, third, and this will be having the 4th term presence. So these two term magnitude will be placed as a 1 and their grouping will be considered. For this grouping simplification result, A is present in complemented and uncomplemented form, so it will get cancelled with each other, and this will be having common value as B bar, C bar. So the resultant for this simplification by using 3 variable Kmap is B bar, C bar. Again 3 variable Kmap, but here the mean terms which are present are 4th and 5th. So here this will be the 4th mean term and this will be the 5th mean term. Its grouping will give me the result. A is common over here, while B dash is also common, but C is present in complemented and uncomplemented form, so it will get cancelled and resultant will be A, B dash. In this next example, we are having 4 terms which are present, mean terms which are present in the expression. Those are 0th term, 1st term, this will be 4th term, and this will be 5th term. So here, instead of having a group of 2 ones, we will have a group of more number of ones, which is of 4 ones to be grouped out. And because of that, as a resultant, we will find out C is present in complemented and uncomplemented form. Also A is present in complemented and uncomplemented form. So A and C terms will not be existing in the resultant form. Only the common term of B dash will existing in the resultant. Now we will go for this next example where the 0th, 1st, 2nd and 3rd terms will be existing. So here let's place one value corresponding to that and we will make the group of these all 4 ones. So as a resultant, here A dash is common, while in this columns B and C both will be present either in complemented form or in uncomplemented form, so they will not be present into the resultant. Only this A dash term will be present into the resultant. So from this 4 examples we can see that when we are making a grouping of 2 ones, the resultant will be a combination of 2 variables. But when we are making a group of 4 ones, that time the resultant will be only a single variable. Now we will go for the next example wherein 0th and 4th mean terms will be present. So here this will not be 4th mean term, it should be the 3rd mean term. So here we can have this as a 0th mean term and this will be as a 3rd mean term. In this example, here we will have the 1st mean term and the 3rd mean term which will be present. So their placement will be 0, 1, this is 2nd and this will be 3rd mean term. So the resultant we can have here A dash and C. Now in this case, we will have this as a 4th mean term and this as a 6th mean term. They will be combined together. Common value is A, and in these 2 parts the common value is C bar. So the resultant will be A, C bar. Now we will have zeroth and second term which will be present. So zeroth term first and here it will be second term. So their grouping will happen. For the grouping resultant we will have A bar and here C bar term. So that will give the resultant as A bar, C bar. In the similar way 0, 2, 4 and 6. So we will have a group of 4 ones. And as a resultant of group of 4 ones, we will have the resultant as C bar. In the same way, you can try for this 4 variable Kmap resultants to be obtained. Now, when such like this, the terms will be given, that is A dash C. So A dash C will be represented in the given part with B value to be complemented or B value to be in original form. So for this part A dash is present in these two rows, but B value will be complemented and uncomplemented. So in these two cells that will be placed as a 1, and here also because we will need the C value to be present, but in these two columns D is present in complemented and uncomplemented form. So here also we can place the magnitude as 1. Now for the resultant of B. If I want the resultant of B, then I should have 3 variables, that is A, B and C should be present in either complemented form or in uncomplemented form. And because of that, here for these all mean term placements, the 1 has to be written. Next is AC dash D. That means we are having A in the original form, D is also in the original form. So D is present in original form over here, and we are having C dash term. That means these term will be common of A, C dash, D, but B term is absent. That means it is present in complemented and uncomplemented form. So for this term and this term, the 1 has been placed. This is how from the given expression, even if all the literals are not present in the given mean term, we can get the ones and zeros to be placed. Let's try for this another example. The first term is AB. That means AB should be common. If AB is common, that means C is present in complemented and uncomplemented form, and this row corresponds for those two mean term representation where AB is common but C is present in complemented and uncomplemented form. Similarly, the second term consists of BC. That means BC will be the common term, but A will be present in complemented and uncomplemented form, and this vertical group of mean terms will represent that case where A is present in uncomplemented and complemented form, while B and C are present in original form. And the third term is A dash, B dash, C dash. So this is a only single mean term representation. It is not a group representation which has been given from the Boolean expression. Similarly, we will try for this last example, which is of B bar. So B bar is present, that means both A and C will be present in complementing form. So A is present in complementing form in this part, in these two parts, while C is also present in complementing form for these parts, where we can have this term as A dash, B dash, C dash, and this term as A dash, B dash, C, while here it will be A B dash C dash, and this will be A B dash C. So A and B terms will get cancelled and only remaining is B dash. Now for the representation of A dash C dash. A dash C dash means B should be present in complemented and uncomplemented form, which is the condition over here. So A dash is present in these two parts and similarly C dash is common, but B is present in original form and in complemented form. Then let's take this AC term. So here A is common, C is common, but B is present in complemented and uncomplemented form. So this vertical ones grouping will give us this result of AC. In the previous parts, we have taken either the Boolean expression, corresponding mean term we have represented, and the mean term presence cell value we have put as 1 in the previous examples. But directly from the truth table also we can get the mapping to be done for this Kmap cells. So from truth table, if we have to map to the Kmap, the output cell value which is existing with 1, that particular corresponding input combination mean term we have to represent as 1. So let's check out from this truth table. Here the first row is having output as 1. So this row will be having the input combination as 0, 0, 0. That means it is the 0th mean term which is present in first row, first column. So it is placed as 1. After this 0, 1, 2, 3, 4, this fourth row is again having the value as 1. And this corresponds to the mean term representation as A B dash C dash. So A B dash C dash will be present over here for this mean term representation, and this will be represented as 1 as it is having output value as 1. Similarly, for this sixth row the output value is 1, but its corresponding input combination is A B C dash. So A B C dash will be present over here. So this mean term we are placing as 1, and finally A B C, these three will be ones corresponding to that output has been presented as 1, and it is represented in this Kmap as a 1. So from truth table also directly we can have the mapping of cell values in the Kmap. Apart from this, the cell value can be specified as a don't care condition. So don't care condition for the truth table means that it doesn't care if the output is 0 or 1. That don't care condition in the Kmap will be considered either as a 0 or 1 as per our need for doing the grouping of the ones or zeros. So here the don't care condition can be treated as a 0, means we are not using that in the grouping of the ones. We are considering the don't care as a 1, which will allow us to make the grouping of larger number of ones, and here we are using that for simplification of the sum of product. Let's check out in this example that this first term, that is 0 term, we have placed as don't. Now the adjacent cell value for this don't care is 1. So to get the simplification to be done, we have to consider this don't care as a 1. But if we are looking for this don't care condition, in adjacent cells of this don't care condition, we don't have any of the ones to be present. That means here grouping of ones is not possible, and that's why here as adjacent cell values are zeros, this don't care will be also considered to be 0 and it will not be used in any of the. Let's now try for this truth table to be mapped into the. So we will go on literally spacing these values of output variables into the given K. So first combination mean term resultant is don't care, it is placed. Second is 0. Third one is 1, which is placed over here in the upper right hand corner. Next is don't care, it is placed over here. Next value is 0 here. This don't care will be placed over here. This don't care will go to this position. This 1 will come over here. And after this there are 3 ones which will be placed here, here, here and at this position. After this we are having this don't care condition. This another don't care will be placed over here. And after that the 3 zeros will be present over. Now if we are observing this don't care and this don't care, if we are considering with the magnitude of 1, then only there is possibility of grouping the 4 number of ones. That's why these two don't cares will be considered to be 1. Similarly, for this lower part or lower row, this don't care, if we are considering as a 1, then only the grouping of 4 ones is possible. So this don't care will be considered to be 1. And then after that the simplification of this group and this group will be obtained, which will come out as r dash t ORed with r s dash. So we will do the simplification for product of sum minimization. The product of sum minimization, when we are doing by using the Kmap, from the truth table we have to pick the values as, because for SOP minimization we are picking the values from the truth table as ones, as POS is a complement of SOP. So one's complement 0 is used for their representation. So let's check now this first condition. A ORed with B ORed with C is a complement value of A dash B dash C dash. So we are placing the 0 for A dash B dash C dash. Next term is A ORed with B dash ORed with C, which is complement value of A dash B C dash, which is this term. So we are placing here 0. The next term is A dash ORed with B dash ORed with C, which complement is A B C dash. So A B C dash is present over here. So this mean term we are presenting as 0. Next mean term which is present here is, max term which is present here is A dash ORed with B ORed with C dash. Its complement will be A B dash C. So that is present over here. So it will be represented as, this is how the POS can be represented into the Kmap. The next part we are going to cover in this lecture is design of combinational digital circuits. So whenever the combinational digital circuit has to be designed, we have to follow these 4 important steps. In the first step, we have to get the problem statement based truth table to be derived. So as the problem statement is going to give us the logical operation explanation for the truth table to be obtained. As a second step, from the truth table we have to derive the unsimplified logical expression. Then as a third step, we have to simplify that logic expression. And finally, based on the simplified expression, we have to draw the logic circuit diagram. So let's take one example for that. The example problem states that design a 3-input digital circuit that will give at its output a logic 1 only if the binary number formed at the input has more ones than zeros. So let's try to put out a truth table corresponding to this problem statement condition. So it is clear that this digital circuit will have 3 inputs and 1 output. So we will have 3 inputs as A, B, C and output as X. As 3 inputs will be present, so possible number of input combinations will be 8 that we will first rewrite. So those will be starting from 0, 0, 0 up to 1, 1, 1. Now it says that the output of that logic circuit will be only 1 only if the binary number is going to have the input with more number of ones than zeros. So in this condition we will have 3 zeros, so no 1, so output will be 0. Here 2 zeros are present, 1 is present, so output is again 0. In this case also it is true that 2 zeros and 1 is present, so output is 0. But here in this case the number of ones are greater as compared to 0 in third state, then in fifth state, sixth state and in seventh state. So corresponding outputs we have placed as 1, otherwise the output is. Now we have got the truth table, and from this truth table we have to get the unsimplified logic expression. The unsimplified logic expression tells us that here the third mean term, fifth, sixth and seventh mean terms are present. So this is the unsimplified Boolean expression in the form of sum of product. After this, for getting the simplification of this expression to be done, we have to place a Kmap. But as the input variables are 3 in number, so we have to use 3 variable Kmap over. In the 3 variable Kmap, 1 variable we are taking in column and 2 variables we are taking in the rows. So the placement of Kmap variables will be as like this. Now we will place one value for the mean terms which are present in the given Boolean expression. So 3, 5, 6 and 7 terms will be present. So 1 is placed for 0, 1, 2, this is third term, this is fourth, fifth, sixth and seventh term. So ones are placed at these 4 positions. Next we have to go for grouping of ones. But as earlier said here, even though we are having 3 ones in a adjacent rows, we cannot group that because we will need the number of ones is equal to 2's power. So we have to give this as a first group, this as a second group, and vertically these 2 ones can be again grouped up. So corresponding to first group, the resultant will be the value of AC. So this will be AC resultant. For this second group, we will be having the result of AB. This is the resultant for this second group. And for this last group, the resultant will be BC. It will be placed over. And then corresponding to this, we have to draw the logical circuit. So logical circuit will give us this as the original variable of A, B and this, but nowhere in any of the terms we are finding the complemented terms, so only the original variables will be extended. Here ANDing of the variables is there, so the 3 AND gates will be placed, and after that 3 ANDing resultants we are going to OR that. So here 1 OR gate for the 3 inputs will be shown. So this is what a simplified combinational logic circuit which has been designed from this given problem state. Let's take one another example. It is for 4 input variables. Output is again a single output. So 4 inputs A, B, C, D and 1 output is specified. As 4 inputs are there, so possible input combinations will be 2 raised to 4, that is totally 16. Those have been placed over here. Now for the output to be generated, what it says is the output X a logic 1 only if the binary number formed at the input is between 2 to 9. So whenever the binary number value is between 2 to 9, at that time only the output generated is 1. At all other times it is So here from binary number 2 to 9, that value of output will be placed as a 1. From this truth table, the unsimplified expression will be written. So unsimplified expression terms that summation, and for the summation from second term up to the ninth term will be present. So 2, 3, 4, 5, 6, 7, 8, 9, those terms will be present. Now from this unsimplified form, we have to get the Kmap to be written. The terms which are present, those should be represented by ones, and the terms which are absent in the expression will be represented by 0. So this is second term, third term, fourth, fifth, sixth and seventh term. Similarly, this is eighth term and this is ninth term, which will be represented by 1. Now the grouping has to be done. For the grouping to be done, I can have this first group of 4 ones. Similarly, I can have this second group of 4 1, while these 2 ones I have to group separate. The resultant from these 4 ones grouping comes out as A dash C, and the resultant for this comes out as A dash B, while this will result into A B dash C dash. Now here you can see the complement terms are also present. So you can see that here dots are existing for the complemented output, which are taken correspondingly for formation of these expressions. So this particular part can be given either in this upper way representation or by this lower way representation, which are very similar to each other. Friends, I think you have understood now how the Kmap is to be placed. It is used for the simplification of Boolean expression. What are the rules associated for doing the simplification of the Kmaps, and how by using the Kmaps we can get the simplified circuits from the given example. So bye friends, and keep learning.